So first, I thought I'd run through a little bit about who we are and what we do, and sort of how that's applicable to cloud moving to the edge. So Leading Edge Data Centers are a data center company. We are in the business of building edge data centers. What I've got on the sort of opening screen of the presentation right now is what we call one of our Titan data centers. So what we really do is build modular data centers in regional Australia. And there's a number of reasons for this. So I'll sort of run through why we're doing it as a starting point. So Australia has a number of challenges at the edge, right? Australia is a big place. Comparative, the east coast of Australia alone is, comparative to crossing most of Europe into Asia in terms of distance and scale. So the biggest challenges we see at the edge are high latency. So we're talking communities that are situated anywhere from 30 to 50 milliseconds away from the closest data center, closest hyperscale infrastructure, closest cloud. And that's a pretty common thing for roughly 30% of Australia's population. It's all aging infrastructure. Everything that was built out there was built when the local incumbent, being Telstra, was owned and operated by the government. So there's a lack of infrastructure. People are generally dependent on single points of connectivity, a single link going into their buildings, supported by a single carrier. Their access to redundancy, to just being able to use multiple carriers for their own resilience is limited. Minimal choice, lack of different options out there, nowhere to host anything. Everything sits in a cupboard in the back room or in a private data center hosted on site. And the ability to access innovative solutions to current problems, right? And how we as a business are addressing this is we're currently building out these data centers. They're all tier 3 modular facilities. We work hand in hand with Schneider Electric to produce these. They've been a great partner to work with. And essentially what we're delivering is we're moving not just the data center, but building a modular data center in these regional communities moves the network connectivity hubs closer to the people. So it allows people to leverage more carriers, better connectivity. Where we create an environment that's capable of hosting cloud infrastructure. We work with the likes of AWS, Azure, IBM to make sure that the facilities that we're building and that we're providing are capable of supporting not just the solutions and the independent cloud solutions that they're deploying at the moment, but are capable of supporting things 5 years, 10 years, 15 years into the future. All the facilities that we're deploying are tier 3 rated, right? So they come with a tier 3 uptime guarantee. We have a multiple sets of infrastructure keeping that up. So we've got dual generators, dual UPS. We've run solar on the roof. We have access to solar grids locally. We've got they're really interesting things, which I'll talk to in a little bit more detail as we move through. But as I mentioned earlier, whilst we're building modular data centers, we're not just building modular data centers. We're building a network of data centers that stretch the length and breadth of Australia. Cairns to Geelong in this image, that's roughly 3,500 kilometres. That's further than London to Moscow, right? So in between there's multiple sites. If you look at this map, the key locations for cloud in Australia are Melbourne and Sydney. Sydney being the primary. You'll see a couple of sporadic pop-ups for cloud in Brisbane, and you'll see some stuff in Canberra focused on Australia's federal government. But outside of that, there's nothing. So as you stretch up to Cairns, that's over 100 milliseconds of latency through carrier network to reach a hyperscale cloud. So the facilities that we build, this image that I've got here is one of our Titan modules. As you can see, the roof's covered in solar panels and lightning conductors because, putting a big facility in the middle of nowhere, it tends to be taller than most things, and you do worry about getting hit by lightning. So what you're looking at here is 75 racks, 375 kilowatts of IT load, average 5 kilowatt rack density, but we've got the ability to push that up to an average of around 10 kilowatts per rack of rack density over time. It's just easier to start out with a lower number. It means less infrastructure that you need to deploy day one. There's actually two facilities there. So what you've got underneath is the data center itself. That's a completely independent facility designed, built by Schneider Electric and onshore manufacturing companies within Australia. And then over the top of it, we've got what we call the LEDC solar shield. So this piece of equipment sort of provides three benefits. It provides a place for us to house solar, which is great. We get, depending on the location of the facility and the angle that it's facing, we get anywhere between 75 to 95 kilowatts off the roof of one of these things. It doesn't run the whole facility, but it's great for offset of power. And the second thing that they do is the facility's lifespan is generally, or the facility underneath is rated for 25 years. With the addition of the solar shield, it puts the lifespan of the facility at 50 years. And lastly, aside from providing a place to put our logo, which everyone in the business is very keen on, it provides an air gap. So what that air gap does is it takes what's our current what a PUE of, the PUE would be 1.35 without the solar shield, and with the solar shield, it takes us down into the sort of 1.26, 1.27 space for PUE, which is great in terms of cooling, right? So you get airflow over the facility, it's shielded from direct sunlight, great benefits, not just on the cost reduction, but on the sustainability side as well. We also have what we call an Atlas, which is a 30 rack module. These are a single facility which is designed and built and as one piece. And before I go into that, I should probably talk about how the Titan's assembled. Titan's actually built in 4 pieces, manufactured in facility, put onto 4 trucks in the middle of the night so we don't ruin the traffic, driven out to site, put together on site, plugged into the grid, plugged into the dual generators, and tested it and set up. And from build to deployment, these things sort of run between 3 to 6 months, depending on site availability and readiness. So they're relatively quick, but they're a large facility to deploy, and they're capable of sustaining more infrastructure for a longer period of time. The Atlas is what we call one of our smaller facilities, and they look something like this. So the Atlas facilities, a cut down module of what the Titan data center is. It houses 30 racks, again, 5 kilowatt average usage, capable of supporting up to 7.2 as standard. With 3-phase conversion, we can run them up to about 22.4 kilowatts, upgradable to an average power load of 10 kilowatts across the racks. These are manufactured in 1 unit, all the wiring done. They're actually deployable in, a maximum time frame is 3 months. So if we have a site that needs to be deployed fast and quickly, you can literally order one of these, ship it out to site, drop it, and have it ready in 3 months. So they still have all the exact same specs as a Titan, dual generators supporting them, dual UPS, M+2 on the cooling. Great facilities, very quick and easy for us to deploy. They have what we call an airlock, which butts up to one side. It's visible on this one. It's not visible on this one. an airlock that butts up to one side and allows for another Atlas to be dropped next to it. So you have a facility that houses 60 racks. All the land sites that we choose and that we contract, they all support multiple deployments of data center. So whilst we start with 30 racks, most sites are capable of supporting up to 120. The sites where we've got Titans generally support anywhere from 150 racks through to 300, right? So it's all dependent on how quickly the sites grow and what's needed. This is what the inside of one of our facilities look like. We deploy the latest state-of-the-art Schneider kit. So everything in there is APC branded. We use in-room DX cooling. All the latest Schneider racks, 600 wide, 1.2 deep, 48 AU high. We've got VESDA early warning systems. We've got smoke and particulate sensors in every rack. It's literally the sort of stuff you see in the latest generation deployments throughout the US and Europe. In terms of security, these are dark sites. So these are unmanned. We have nobody there to watch the doors. So we rely heavily on security. We've got every facility has 36 plus AI-driven cameras that monitor and maintain the facility. We've got 5 levels of biometric access, including encrypted Bluetooth applications to get you in the gates and the doors, coupled with facial recognition to get you through into the data hall and into your rack. So it's a solid combination of security technology to get you in, and the facilities themselves are monitored 24/7, and we have response times within 15 minutes for security. So whilst they're unmanned, they're very tightly kept, and they meet government levels of security. And so this sort of comes to the idea of why we built and why we started deploying this data center network. So traditionally, especially in Australia, right, we see 2 key hubs where everything, whether it's kids doing work on a application based in Azure, whether it's hospital running its database in AWS, whether it's a utility, running its corporate database within IBM. These all sit within 2 major metro centers. And what you see is the lack of general people to be able to take, or general businesses, SMEs, MSPs based out in these regional areas to take advantage of the true capabilities of these clouds. So as we've been building out, we've sort of been building around key connectivity centers within Australia, and moving that, what we call that trombone effect, from going straight through a major metro hub to hubbing out of its local region. So, we use a hub like Coffs Harbour or Wagga Wagga, and traffic will go from Wagga to the data center, hit the local cloud hosted there, and then back to the user. Now, what works really well in this sort of topology is it allows people to leverage our diverse carriage of backhaul. So we have multiple, fiber paths coming from our data centers, and being in Europe, you're probably used to having the advantages of many carriers and many fiber networks and backbones that go everywhere. Having lived there for 7.5 years, I'm very familiar with the telco landscape. Australia is not quite as blessed in the amount of infrastructure that we have. So finding diverse paths out of regional townships and regional centres becomes quite challenging. So where we provide a great advantage for lots of these users and companies and businesses that want to take advantage of what we do is we allow them to leverage our backbone, right? And so that means they can build hybrid cloud solutions. They can put their own private kit in our data center, host other companies in it, and then they can connect back into major hyperscale facilities and use our dedicated backbone with high capacity, lower latency, better cost, all those sorts of things. And so what we're really trying to do is reduce that time for people to be able to access cloud down to the sort of sub 3 millisecond space. And this number sort of gets thrown around a lot. The 5 to 3 milliseconds is that sort of, I guess, what people say is that user experience bracket, where if you're using any complicated application, anything that requires a large amount of compute, it really needs sort of sub 3 milliseconds for it to, or sub 5 milliseconds for it to be usable and to be, so people aren't sitting there watching the spinning wheel of death while they go and make a coffee for a CAD file to load, or a very dense image with multiple data points to load. And so what we're building this network for is to help move that cloud infrastructure that hosts what these people are using out to the edge so that it's more accessible and user-friendly. What we're also finding that it's doing is promoting innovation across the regions. So talking to my point earlier, this is what this map represents in Australia is people within 3 milliseconds of one of our data centers, and that's based on speed of light over glass with a distance variation of about 1.7. So it's relatively accurate given the averages of what fiber paths look like within Australia. And that covers off about 90% of Australia's population on the East Coast there. And the sort of, the sort of areas we're seeing innovation in is we're seeing people like universities who are running HPC and doing work in agri-tech, right? So they're running drones with high definition cameras that are filming crops and looking for, color and specific cotton crops that indicate high nitrogen content within the soil. And so they know that the crop in that particular area is going to be over the next 5 days requires, X amount of nitrogen in the soil, X amount of other additives, and they can make those decisions in real time and process that data locally rather than sending it, having multiple 100 gig links back to a cloud somewhere where they process that, bring it back. They can host the capability to process that locally, and they can, leverage that low latency to make real-time decisions for things like self-driving harvesters, drones that drive weed or pest control robots that follow them along the thing, identifying weeds and spraying them as they go. So we're seeing the ability for people to use that and process that locally as one of the key use cases. The other sort of thing we're seeing is, I guess we call it equality of access to digital or to cloud, right? So, Australia has, I think New South Wales alone has something like 2,200 schools, and you've got students that sit in Sydney that are 1 milliseconds away from the hyperscale cloud that hosts their environment, and you've got children which sit, right out in Moree, for example, which is way out northwest. I'm just naming places that probably anybody in the school doesn't know, but they're 30 to 60 milliseconds away. And that sort of, that's not equitable access to education as we see it. You've got not only is there latency, but there's congestion on networks, there's downtime, there's connectivity issues. There's all sorts of bits and pieces that go wrong from the source to the end user. So the ability to push that out and the conversations we have with the major cloud providers and even the smaller guys who provide specialty applications to the education sector, it really changes the conversation for how these kids get access to cloud. What I've got here on this particular slide sort of shows where we fit into the ecosystem. So we've got the network back into major capital cities, got data centers interconnected by 10 and 100 gig waves, all diverse, and they take the lowest latency path possible where they can between data centers. And we have them connected into what is Australia's wholesale fibre access network run by the government, which is NBN Co. And that allows people to access our facility locally rather than happening through a metro region. And what we also do is we deal with a number of the major carriers in Australia to work with them on how they're distributing 5G cloud access points. So rather than deploy a kit on the bottom of every tower, where it makes sense, they consolidate or can consolidate within our data centers. And this sort of shows, we talk a lot about in our business about bridging the digital divide, where regional townships, regional cities don't have access to the same sort of digital equality that people in a metro region have. And over the years, we've seen the content and internet access addressed, and that's sort of been the first digital divide: fibre to prem, 5G access, or available 5G over large areas. And now we're sort of hitting that second digital divide. It's started, we're pushing more private clouds out to the edge, we're pushing more content for retail networks out to the edge. So, somebody streaming a 4K video isn't waiting 20 milliseconds over a poor connection that's congested 15 times for it to buffer. That's sitting right at the end of their retail connection. And what we're sort of seeing as that next step is the step into the AI, VR, real-time decision-making IoT space. And that's sort of where we see one of the primary drivers for growth in that edge cloud market in the future. The sort of industries we've been working with, we work a lot in government, agriculture, infotech. Telecommunications is a massive one because changing the way people consume cloud primarily means changing the way people connect networks, right? That's probably been the biggest challenge to date, is driving the change through telcos and helping them rebuild their network so that connectivity is local. It takes load off of long-haul network links. It allows people to peer locally and distribute traffic locally. Education, healthcare, property and development, hospitality, financial services, having a financial transaction gateway hosted locally means when some of these towns, cut off from the internet for long periods of time, it basically means everyone there that doesn't have their own transaction capable infrastructure on site loses business, right? So this is a massive one for us as well. Consumer and transport and manufacturing is huge as well. We see so much growth from the manufacturing industry. COVID's taught us that you can't import everything. So there's a huge amount of manufacturing coming back onshore, which I'm sure is reflected across Europe and the US as well. Look, I think the long and the short of it is we're really providing that critical infrastructure that helps place regional communities in places like Australia grow by solving their core connectivity problems and helping address that growth of population migration. And that's the end of the presentation that I've got. Look, I'd love to field questions.
Thanks very much, Daniel. That was great. Just a couple of questions, if you're happy. So, just going back to what you were talking about, what kind of were the big challenges or the key takeaways that you experienced when you were, deploying these data centers kind of further out and having to sort of build them to time and to scale? What would you take away from that?
What are the key challenges? There's many key challenges. So look, I'll stop sharing the slide. So I think primarily the biggest challenge that we have as a business is finding the right A, location, and B, building that connectivity base of telcos. So all our facilities are, we have to be over 1 in 500 year flood events. And I don't know if anyone's watched what's happened in Australia over the last couple of years, but we've seen last year there were, I think, 3 1 in 100 year flood events, which sort of talks to what's going on in the globally in the sort of climate space. But finding a location that's over the 1 in 500 year flood event, people build towns next to rivers. It's really smart. So they're really tough to find, and you have to find that in conjunction with accessible power, and you have to find that in conjunction with accessible telecommunications infrastructure. Right? There's no point in spending X amount of money building a facility that then requires every carrier in the region to spend, and the equivalent in rebuilding fiber networks to meet it. Right? So those are sort of the two biggest challenges.
And what you're saying is, as more and more devices, are being connected at the edge, and especially devices that, are using a lot of data. Do you think this is where, especially in countries like Australia, this is where we're moving, the cloud's going to be decentralized? And kind of what do you see the landscape like in 10, 20 years?
Yeah, look, very much so, right? So I think we're a little bit ahead of the curve when it comes to Australia. We don't have a huge population density, but I think as we go forward, we're going to see the sort of adoption of smaller and smaller modular data centers deployed closer and closer to end user consumer points as we sort of roll out. I mean, we see right now, or we have conversations right now with multiple cloud providers who are scaling down their deployments smaller and smaller to be able to address smaller markets. And in that sort of interim space, while we're waiting for these people, or while these cloud providers are condensing their application stack to run on smaller and smaller chunks of infrastructure, we're seeing lots of smaller cloud providers sort of jump into that gap. So we have, a number of what we'd call, Australian local cloud providers that have sort of stepped into that gap of hyperscalers and are filling the needs of a lot of these regional communities, providing, CDN networks and providing local cloud and compute facilities. But yeah, I think that's going to condense, and we'll see smaller. You'll see 8 rack modules and you'll see 4 rack modules sitting closer and closer to where people are consuming.
Brilliant. Thank you. If you're happy, we're sort of going to wrap things up there. I don't know what time is it in Australia at the moment?
8:30.
Oh, okay. So it's evening. Oh, thank you very much.
It's not that bad. I got the kids to bed half an hour before this. It was easy.
There wasn't any panic last minute. You got to get to bed right now. I'm going to be somewhere.
Exactly.
Thank you very, very much for joining us then so late. That we really appreciate it, and thank you for joining us this morning.
No worries. Look, thank you very much for having me. Really appreciate it.
Good evening. Bye bye.
Cheers.